Welcome to another exercise in a workbook statistics. This time I'm going to talk about an exercise focusing on the so-called homogeneity test. So let's have a look at the exercise. In the context of a current study, women and men are asked about their opinion on a new source. They had to blind taste it and then rate it on a 4-point scale. The results are as follows. And we have for men and for women the 4 possible different outcome categories. Our task now: test by using a suitable test whether significant differences exist between the evaluations of men and women. Assume that a margin of error of 5% is considered acceptable. Well, we could do different versions here. Theoretically, we could run a 2-sample t-test or ghost test, but since we have the data already in classified form, something much more suitable would be the homogeneity test, testing whether both of these two groups, which are distinctly different, share a common distribution. So more or less have a common underlying structure. Well, if we want to do this homogeneity test, we have first to expand this table slightly, and that's what I'm going to do in the beginning. So I'm going to copy the table as was in the exercise, and I'm going to add one additional row here, where I'm simply going to sum up all the frequencies we have for the 4 different categories. I'm doing this for the men and for the women. And then I'm calculating this theoretical common distribution. How am I doing this? Well, I'm going to add up these two numbers. So for very good, I have 26 men, 24 women. So I get 50 people in total. And I'm going to divide this by the sum of the two sums. So here I'm going to add 113 and 162, giving me 275. So I'm going to divide 50 by 275. Then I'm going to take those two together. I have 106 divided by 275. That's how I get my different probabilities for my common or theoretical common distribution. So under the assumption that they share a common distribution, that's how the common distribution would look like. And once I have done this, I'm going to multiply all these probabilities once with the overall sum for men and once with the overall sum for women, giving me then the expected frequencies for men and women. So this 20.54 results by going 0.1818 times 113. The 29.45 for women results by going 0.1818 times 162. The other ones similarly. Here, this one, for example, rather good for men. I'm going with 0.3855 times 113. For the women, 0.3855 times 162. Then, the result is I have the actual numbers for men and women, and I have the expected numbers for men and women, and I can compare them. Do these probabilities, these frequencies actually meet these expected frequencies, or are there significant differences between them? So how do I compare this? Well, I simply apply the chi-squared formula, and that's how I get my test statistic. So for each entry, 4 here and 4 here, so 8 in total, I'm going to calculate actual frequency, so in the first one the 26, minus expected frequency, that's here the 20.54, in parentheses, squared, divided by expected frequencies. Now I'm going to do this for the next one, here for the women. I have 24 actual minus 29.45 expected, squared, divided by the 29.45 expected. And I'm doing this for all 8 entries. So here I have 8 different terms. If this might be a bit too confusing for you, what you could also do is expand your table even more, make one additional column for group 1 for the men, one additional column for group 2 for the women, and then do all the calculations in each of these different fields. This way you will always have like the direct comparison, and you know that you calculated everything you needed and you calculated this correctly. Well, that's, however, how we do this here, also for the simple reason that I do not have any space left on the right of this table. In either case, if you did this correctly, you get these partial results, and as a final result, a value of 14.9307. That's then our test statistic. That's what we're going to use to compare to the reference value from the table. So that's actually the next thing and the last thing we need before we can conduct our test. That's the reference value. How do I get the reference value? Well, for the homogeneity test, that's simply chi-squared, I minus 1, 1 minus alpha. The I, that's the number of categories. Here I have 4 different categories, the 4 different rating outcomes. So I have 4 minus 1, giving me the 3 here. Then I have 1 minus alpha. Alpha, that's my margin of error. In the exercise text it said alpha, the margin of error should be 5%. So I'm calculating 1 minus 0.05, giving me 0.95. So in the table, for the chi-squared distribution, I'm looking up this value. There I find 7.8147. With this, I have everything I need to actually conduct my test. That's simply comparing the test statistic from the previous slide with the reference value up here. I see that my test statistic is definitely larger than the reference value. This means I can reject my H0 hypothesis. In the context of the homogeneity test, the H0 hypothesis means that both of the two groups, both of the two samples, share a common distribution. Well, here it has to be rejected, so they do not share a common distribution. So applied to our question, can be assumed that men and women evaluate the products significantly different. They do not share a common distribution. Well, that then concludes this exercise, which I hope you enjoyed. I say goodbye, therefore, and see you next time.